Alright, in this video we will be discussing the limit definition of the derivative. There are two versions. There's the version at the left, f prime of a is equal to the limit as x goes to a of the difference quotient f of x minus f of a over x minus a. So you may have seen this in an algebra class or a pre-calculus class. This part right here is called the difference quotient. And alternatively, we could use the definition f prime of a is equal to the limit as h goes to 0 of f of a plus h minus f of a over h over here. And again, that is another version of the difference quotient you may have seen in a previous class. Now, the goal of the limit definition of the derivative is to try to find the slope of the function using only a single point. Now, before calculus, if you wanted the slope, you could only find it if you had 2 points, an x1, y1, and an x2, y2. Now with limits, we can find the slope using only 1 point and get around the whole issue of division by 0, almost always with either a factor and cancel or conjugates. That's for the basic examples. So the limit definition of the derivative is going to give us the slope of the function at x equals a. Sometimes you might see this a here replaced with an x in all of the locations, and that is fine too. Just some quick tips about these two versions. All things being equal, if you are allowed to choose, let me just walk you through what the trade-offs are. So this version over here often starts easier and ends with more difficulty, but sometimes that's worth it. And this alternative version often starts with more difficulty and ends easier. These aren't hard and fast rules, but they're sort of general. Pick your preference based on where you want the difficulty to be. Having taught thousands of students, I find that students using this one get farther in the task or tend to get more right answers. All right, in this example, we're going to use the limit definition of the derivative to evaluate f prime of 5 if f of x equals 3x squared minus 4x plus 1. We'll actually do this using both definitions. My recommendation to you is to find which one you prefer and stick with that. Using the definition that we encountered first, which is the limit as x goes to a of f of x minus f of a over x minus a with a equals 5. This gives us the limit as x goes to 5 of f of x minus f of 5 over x minus 5. We need to evaluate what is f of 5. So a little side quest here, f of 5 is equal to 3 times 5 squared minus 4 times 5 plus 1 is equal to 75 minus 20 plus 1 is equal to 56. So this equals the limit as x goes to 5 of f of x, which is 3x squared minus 4x plus 1, minus f of 5, which is 56, all divided by x minus 5. So what we've done is we've replaced f of x with its definition, and we've replaced f of 5 with its value that we calculated. And we will proceed to do some algebra. So the numerator is going to be 3x squared minus 4x plus 1 minus 56 is minus 55 over x minus 5. Now we do as we always do with limits, we just try plugging in x equals a and see what happens. So this will be 3 times 5 squared minus 4 times 5 minus 55 over 5 minus 5. You do some arithmetic, you're going to find 0 over 0. And if you'll recall, when we see 0 over 0 with rational functions, our technique is going to be factor and cancel. I have some videos on that. So this is going to be limit as x goes to 5. Now, the pro tip is, if you know factor and cancel is the thing you're going to do, then one of the factors on top, you should guess that it matches the factor on the bottom so that the cancel can actually happen. And then you just see if that actually checks out. So if that is an x minus 5, we're going to need a 3x in the first term of the second factor, and we're going to need a plus 11 in the second term. And now we're just going to double check if we FOIL this out, do we get the 3x squared minus 4x minus 55? So that checks out. Now we have factored, so we get to cancel. We now have the limit as x goes to 5 of 3x plus 11. We get to plug in the 5, and we're going to see 15 plus 11 is 26. To conclude, we say f prime of 5 is 26. Alternatively, we could use the definition, the limit as h goes to 0 of f of a plus h minus f of a all over h, and here a is equal to 5, and so this is going to be the limit as h goes to 0 of f of 5 plus h minus f of 5 all over h. Now we found f of 5 to be 56. Now we need to find f of 5 plus h. So we're going to do a little side quest. F of 5 plus h, that's going to be equal to 3, 5 plus h squared minus 4, 5 plus h plus 1. Don't forget we actually need to FOIL this. So this is going to be 3 times 25 plus 10h plus h squared. If we FOIL that out very carefully, minus 4, 5 plus h plus 1. Now we're going to distribute these values, these coefficients. We get 75 plus 30h plus 3h squared minus 20 minus 4h plus 1. Simplifying this, we have some like terms. 75 minus 20 is 55, plus 1 is 56. 30h minus 4h, so let me just underline these so we can see. 30h minus 4h is 26h, plus 3h squared. All of that lives inside this block right here. So the result here is the limit as h goes to 0 of that result, 56 plus 26h plus 3h squared minus f of 5, which we found to be 56, all over h. Now, some commentary here. I had mentioned that this version of the limit definition tends to be more difficult at the beginning of the problem, and it finishes easier. So this is the pivot point toward the finishing, and you'll see that it finishes easier. Here, the difficulty that most students face is surviving this algebra without making an error. And those students that do survive that algebra without making the error, they get all the way down to here correctly, and they don't replace the entire object here with that result. What those students mistakenly do is they just replace this part with that result, and they end up with an f of this big mess here, and then they cycle back through and get lost in the jungle and never make their way out. So this particular method for the limit definition of derivative tends to scare a lot of students away because they get lost before they ever reach the pivot point where everything starts to get easier. Okay, getting back to this, we can see that 56 minus 56 cancels, and this is the limit as h goes to 0 of 26h plus 3h squared all over h. If we plug in the h equals 0, we're going to get 0 plus 0 over 0 is 0 over 0, so we're going to factor and cancel. And this is what I mean by finishing easier, is the factorization and the canceling is quite straightforward here, because we just have to pull out an h, and then the h's cancel, and we have the limit as h goes to 0 of 26 plus 3h. And now when we plug in the h equals 0, we're just left with 26, which is what we had before. And in conclusion, f prime of 5 is equal to 26. All right, we'll use the limit definition of derivative to find f prime of 3 if f of x is equal to 1 over x plus 3. Our two choices are the limit as x goes to 3 of f of x minus f of 3 over x minus 3, or the limit as h goes to 0 of f of 3 plus h minus f of 3 all over h. Let's just start both of these and see which one we like better. So this is the limit as x goes to 3 of f of x. F of x is the fraction 1 over x plus 3. And f of 3, let's just do a quick little side joint here. F of 3 is 1 over 3 plus 3 is 1 over 6. So the at minus 1 over 6 goes here, and in the denominator we get x minus 3. Over here we're going to get something pretty exciting. F of 3 plus h is going to look like, well, we just replace the x with a 3 plus h. So this gives us a 3 plus h plus 3 minus f of 3, which we found was 1 over 6. And this simplifies to 1 over h plus 6 minus 1 over 6 over h. Now, the one on the left, I've already worked out in another video. So that involved a factor and cancel technique, getting a common denominator, and we concluded at negative 1 over 36. You can watch that video for more details. This one over here we have not worked, and this one is, I mean, obviously it's going to end at negative 1 over 36. It sort of has a strong resemblance in structure, and so the technique will be the same. We're going to need to get common denominators upstairs, do some maneuvering, some algebraic massaging, and then we'll be in a position to factor and cancel. So we're going to get the limit as h goes to 0 of 1 over h plus 6. Give myself some space to build my common denominator, 1 over 6. And common denominators need to be built through multiplication, so I'm going to multiply this by 6 over 6, and this one by h plus 6 over h plus 6. And that's going to give me this monster fraction where h is on the bottom, and on the top left I'm going to have a 6 minus the top right, which is 1 times h plus 6. And then that's over 6 times h plus 6. Remember to watch out for this minus. Now we distribute this minus and continue with the algebra. 6 minus h minus 6. That's over 6h plus 6, and that is all over h. Now the 6 minus 6 cancels, and this is equal to the limit as h goes to 0 of negative h over 6h plus 6. All of that is over h. We're going to unsuppress the silent 1. We're going to keep change flip. And this is going to produce the limit as h goes to 0, negative h over 6h plus 6 times, and keep change flip, so 1 over h. And we can see these h's cancel. And we get negative 1 over 6h plus 6. And that's going to equal negative 1 over 36, which is what we knew from our previous work. And so in conclusion, f prime of 3 is equal to negative 1 over 36.